Excellent. Welcome. Yes. Come learn about vapor pressure and boiling in our seventh lesson on physical behavior of matter. So in this lesson, we're going to cover the learning target of what's going on with pressure and boiling. So there's a relationship that we show on table H between boiling of liquids and pressure of the atmosphere. Okay, you may have heard you got to boil noodles for a longer time if you live in Colorado than if you live in Florida. And now, why is that? Well, it has to do with pressure. So what you have to realize is that atmosphere is pushing down on all of us evenly all the time. There's like a column of air above your body that goes all the way up to the top of our atmosphere. And the weight of that column is what we refer to as 1 atmosphere of pressure. This entire column of air sitting above my head is pushing down. I don't feel it because I've grown up this way. I have come accustomed to existing at 1 atmosphere of pressure. You may feel this changing in your life as you go up a big mountain or a hill in a car. You feel a bubble in your ears starting going, okay? Or if you go down into a deep valley, you kind of feel the pressure in your ears start to change. So the column of air above you has shrunk or gained, increasing or decreasing your pressure. And you feel it, but you go like this, and then you can equilibrate that pressure. Well, that pressure has an effect on molecules and their ability to boil. Okay, when a liquid wants to boil, it's trying to turn into a gas, but it's got to push against all this gas that's already sitting on top of it. So if the pressure on top of it is greater, it's going to affect how well that liquid can boil, pushing back up. So boiling in vapor pressure is a push me, pull you scenario. The hotter the liquid gets, the greater pressure, vapor pressure, it pushes up on the atmosphere. And when the liquid's boiling or heat gets high enough to exert more pressure than the atmosphere pushing down, it will burst into a gas, and that's what we call boiling. So the new definition of boiling for you is that when vapor pressure equals the atmospheric pressure pushing down, you get something to boil. Now, there's a few things that we could do to manipulate these things. We could change the amount of atmospheric pressure, or we could change the temperature of the liquid that we're talking about. Okay, so pressure, what is it? How is it measured? Well, pressure is a force created when gas particles collide against the walls of a container. Pressure is only created by gases, okay? It's measured in many different units. The ones we use here are kilopascals, kPa, or atmospheres. Torrs and millimeters of mercury are other units of pressure that you might find around in life. Other things like bars as well. But we only focus on atmospheres and kilopascals. Okay, standard temperature and pressure. This is always going to be a stumbling point for people, but standard temperature and pressure is 0 degrees Celsius, 1 atmosphere of pressure. So it's freezing point of water, and 1 atmosphere of pressure is STP, standard temperature and pressure. It's 1 atmosphere is equal to 101.3 kilopascals. So those two units are very closely related. There's a conversion factor. Memorize it. Okay. Atmospheric pressure. It's the pressure created from the weight of all the air pushing down, as I explained. On top of you, on top of this desk, on top of my cell phone, all of it. Atmosphere is pushing down all the time. What is vapor pressure, though? Vapor pressure is the amount of pressure that a liquid is exerting on the atmosphere as it's trying to change into a gas. It's pushing up. So my tea here is a liquid. It's warm. Sometimes you can see steam coming off of it because those molecules have beaten atmospheric pressure and they've turned into a gas. They're pushing up out of this cup against the atmosphere pushing down. If this liquid in here was much hotter, it would be boiling and we'd see more steam. It's cooled off for a little while, so it has released some of its energy exothermically to the environment around it. The normal boiling point is the temperature at which things would boil under 1 atmosphere of pressure. That's normally their boiling point. That's what normal boiling point means. Normally, what temperature would they boil at? Well, normally is 1 atmosphere. So this is the temperature it would boil at 1 atmosphere. Enough said. The boiling point of a liquid can change, though, as we change the pressure above it. If I put more pressure on top, the liquid pushing up is going to have a harder time boiling. If I remove the pressure from the top, the liquid's pressure pushing up will have an easier time boiling. And that is what reference table H is trying to show us. these curves, as they increase, as the temperature of the liquid increases, the pressure it puts off increases as well. So it's a direct relationship, logarithmic, but direct. Okay, so example of types of problems here. What is the vapor pressure of water at 50 degrees Celsius? This is a graph reading problem. Let me show you how to do it. 50 degrees Celsius, vapor pressure of water. Well, you go to temperature, 50, and you trace up until you hit the water curve right there, and then you read over. And for me, on this chart, it looks to be, about, let's see, I'm using my close-up version of it, about 12 to 15 kilopascals. That's what you'd write on the line, 12 to 15 kilopascals. Another type question. What's the vapor pressure of water at 80? Same thing, graph reading problem. You go to 80 degrees. You read up until you hit the water line. 75, 80. 80 is right here. You read up till you hit the water line. You read over, and you determine your value. I think it's not quite 50, a little bit less, maybe 47, 48 kilopascals. Okay. And that's all, folks. Okay. Sorry for the interruption, but this is how you use the reference table. Talk to you later.